Thank you, Carlos, for making this happen and inviting me to be part of this. Should start from the beginning. So I'm going to talk a little bit about models of using MOOC hybrid pedagogies at the physics department at MIT. My name is Saif Rayyan. I'm a lecturer in the physics department. I was a postdoc in Dave Pritchard's Relate group. I worked with him on creating the flipped classroom that he talked about before. Then I moved on to the physics department to help the faculty create their MOOCs. We've done 5 so far. I carry a title of Digital Learning Lab Scientist at the Office of Digital Learning at MIT. So MIT is a little bit different in a sense that they have the MITx fellow community that works on creating these courses, and people like me live in the department. They don't live in the Office of Digital Learning. Which is nice because what that means is that we're really more connected to the teaching that happens on campus. And we actually use a lot of the MOOC material and content and technology in our classes. This has been a very strong thing from the beginning at MIT. So I'm going to talk a little bit about the physics curriculum. And in MIT, we like to use numbers. So physics is number 8. And 801 is the... I guess this is not working. So 801 is the physics course. It's the freshman course. And Dave's course was a derivative of 801. 801 and 802. So our experiments with MOOCs, really, the physics department wanted to experiment across the spectrum, not just with for the first introductory freshman classes. But so we've done the MOOC and we've done the residential. And you see that here, everything that we've done in the MOOC was also in parallel happened with implementing some blended component in the classroom. Early on, very early on, we realized that even after Dave's course, that if the 2 components were not identical, we cannot sustain either one of them. It's just you end up in a case where you're running 2 different courses, and it becomes unsustainable for the physics department. So we're hoping that if we wanted to continue this, both have to be the same, really run from the same content. I think that there's a view on MOOCs that you create this course and you put it out there and it lives on its own. And I don't think that's true. Anyone that taught knows that courses are alive, they change, they evolve, and the only guarantee is that you need to keep teaching the same course if you want it to stay alive. So we've done 805X, which is Mastering Quantum Mechanics. This is Quantum Mechanics 2. So we thought that this is a junior-senior course. It's one of the courses that MIT is very proud of. It's not offered at all institutions. So we thought that this fills in a gap in the offerings that are out there. It also helps us in increasing the flexibility of our offerings. So if we can offer this somehow in a blended format and we increase the times that we can offer this course, I think this is one of the ideas that we can do. On the opposite spectrum is 8.EFTX. This is a 3rd-year graduate course in quantum field theory. This is a particle physics theoretical course. The requirement is quantum field theory 3. So basically, students who take this course have taken 5 or 6 courses in quantum mechanics and quantum field theory before they get to this course. That course is only offered really at MIT. The person who created the theory, the effective field theory techniques, is at MIT. So that's the opposite spectrum where we have this course that's not offered anywhere else. The only place to take this course is by really getting the notes from OCW. So we thought that, we can create a community really for people who are interested in this material. But this is targeting graduate students, so they have different needs. And in this talk, I'm really going to talk about the 3 different implementations, how they're different, and why we made a lot of these decisions that we made. So I'm gonna say a little bit about why MOOCs. Really, the number one thing that we're interested in MOOCs is providing immediate feedback. In physics, if you don't do physics problems, you're not going to learn physics. And online, you can do physics problems and you can get immediate feedback. And we believe that this really helps your learning. Dave Pritchard have shown that Mastering Physics, which is the program that he created for tutoring, had the biggest impact on students' grades. And we have a lot of evidence that this actually helps the students. You can do physics online. I can tell the physics faculty that you actually can use a blended component, and students can do physics online in a more or less can provide them with an equivalent experience, like you're really doing the same material. I'm not watering this down, I'm not cutting back on the material, I'm not cutting back on the assessment. We can actually do it. On certain instances, we're not 100% sort of to the same experience, but in certain instances it's actually better. Some aspects are better. Also, we want to use data to improve teaching and learning, and this includes not just research but also resources. We've been teaching the same material for years, and we don't have data on how well students did on this problem or that problem. I'm hoping to get to a point where we actually use all this data that we get from the content to improve it, and we're doing a lot sort of to get there. So the first course, Introductory Course 801 Teal, this is a picture of the Teal classroom, Technology-Enabled Active Learning. We have a studio physics where introductory physics is taught this year. John Belcher transformed the lecture-based course to go into this course. And now the biggest question is, you know, this is like the dream of anyone who's working in educational technology, to sort of put in something where students can learn collaboratively and discuss things together. So why would you want to change that and send the students online to learn physics? I mean, this is one of the challenges that faced us when we created the MOOC. So we created the MOOC, and the MOOC is the only way that some people might be able to learn because they don't have access to that active learning. But if you use the platform with this class, the first thing that you want to do is not impact the active learning that happens in class. And that was a very important thing in our design. Is like we could not, we knew that this helped the students learn, and we did not want to impact it as much. So we have about 600 to 800 students. And again, in terms of scale, when we did the 801X and 802X MOOCs, we had around 17 to 1,800 people finish the course. We probably, if we do the course now, we'll get much lower numbers because there are many more MOOCs out there. So it's a large scale to handle 600 and 800 students. Some institutions teach 1,500 students or 2,100 students just introductory physics. It is a large scale. The first thing is not to harm active learning, so we did not cut any class time. Since the students spending all the class time in discussions, we did not want to cut the class time. We focused on immediate feedback. We thought that the online platform can provide immediate feedback. It's providing an interactive component for the parts that students do outside class. So that's what we tried to do. And that included mainly two things: what people do before class and what people do after class. One other thing is we want to integrate all resources and data in one place. One of the things that our students complain about is that we give them links to 5 different sites in day 1. They have no idea where to go. Things are not compatible, they're not working all the time, so we're really trying to put everything to be connected through the MITx and the edX platform. So we give the students one page. This one page basically contains as much as possible, and if you needed to go outside, there will be a link, so you don't need to remember where you're going. Also, one project that we're working on with Dave is this is really Dave's idea, is building a library of content. Put the content that MIT Physics Department has for the freshman physics in one place so that teachers can go there, they can see the content, they can build assignments from it, they can see analytics about how students performed in this content, is it good or not. That's really the ultimate goal, ultimate dream, is to make things, I mean, this would be our setting point for faculty, that you can actually build your class in easy and in very short time. So we had reading assignments, which we replaced. I'll talk about this a little bit later. We had online homework. We had written homework with online check. This was a surprise for me. This was very popular with the students. Students did not like to submit everything online. They liked when they could check things online but still submit a written solution. We're starting to do a little bit of research on that, but cognitively, my thinking is that, especially for a freshman, I look at a problem online and I quickly make the decision that this is an easy problem I can do in my head, or this is a difficult problem I need to pull a piece of paper and to sort of really try a few things. I don't think freshmen have, people when they come into school have that that discipline or that sort of expert behavior. So if they do things online, they tend to try to do things online on the screen. They get stuck. But if you expect them to write a solution, they're more likely to start writing the solution. So if they make a mistake, they have a written solution that they can go back to and they can troubleshoot their mistakes. So I think that is making a little bit of a difference in how they do things. We're also using things in class. So we're actually having the online check support the group learning activities, and this is something new and we're expanding more and more with it. This also talking about teachers, we cut back around 2 hours a week for our graduate students, just putting tedious data into the platform, just moving things from one spreadsheet to another. If you're teaching a course of that size, 600 to 700 students, you need to make sure that all data is in the right place. Our gradebook has about 100 items in it because there are a lot of assignments, in-class work, experiments, and so on. So one of the results that I like to show is that our students love this. I mean, when you ask the students, should 802 continue using the MITx platform? And 95% said yes. This is huge for MIT. Our students don't like anything, don't agree with anything. There is always something wrong with it. When we ask them that should other courses use MITx, the answer is very high. It's a little bit less high because the students are still sort of careful about online learning. When you say online learning, they get scared a little bit because they think that you're going to send them online to do things on their own and they're not going to get any support. We also ask them to evaluate how useful the different activities that we do in our blended format. And if you see here, checkable answers on MITx for written problems get the highest, 79% rated extremely helpful, another 13% rated it very helpful. This is the highest sort of approval that we got from students on an activity that they think that helped them learn. Reading assignments were not that popular. Not all students like to do the reading assignments. I think there was almost a split. So half students basically thought it was useful. Half of them thought it was not useful. One of the challenging things is basically expecting the students to do an assignment before class 2 or 3 times a week. Also, the idea is that in flipped classroom, you expect the students to come in ready for class. But what if they're not ready? What if they need actually more time to get this material? What we did is that we changed this to become, instead of becoming a pre-class assignment, we gathered all the reading assignments into one, and we made it due after class. And the concepts that students could do it before class, but they had to do it after class and before they start solving the homework, because they needed to make sure that they got the knowledge to go into doing the homework, which is more challenging. You can ask me more questions about some of these items if you're interested later. But I'm going to move on and talk a little bit about 805X, quantum mechanics. This was an experiment where, in addition to the MOOC, we offered an online version of MIT to the MIT students. This was in the off semester. The course is usually taught once a year in the fall semester. So we decided to do it in the spring. Limited to 20 students. We pre-selected the students. We wanted to make sure that we get the students who wanted to accelerate. Somehow they needed this course to move quicker in their studies. And we didn't want people that thought, this is an online course, I don't need to spend as much time on it. It's mostly online, same content as the MOOC, but it's in a different section on the private platform, because these are still undergraduate students. We needed to provide certain things like grade books and extensions, which are not really offered through the MOOC. So the course, this is the traditional course on the left. It had lectures, 3 hours a week. It had recitations where students get together with the professor in smaller groups, and they work mostly on solving problems. Homework is really the huge part of the course. I mean, we expect students to spend 9 hours a week. Whenever I ask someone the estimates, officially we should say 7 hours. In reality, they spend more like 9 hours. It's anywhere between 5 and 12, really, when it comes to the students. And pen and paper exams. So when we created the MOOCs, this is sort of the, if you have a traditional lecture course, we cut the videos of the lectures into smaller segments and we label them. We added a lot of what we call checkpoint exercises that are conceptual questions. We had to come up with 200 conceptual or short questions in quantum mechanics, which was a huge task. This is one of the parts where it's for the faculty, you know, you're forcing MIT faculty to think about changing the way they ask questions, which I think is one of the greatest things about doing MOOCs, is that it has the faculty question the things that they usually do all the time. It's a slow change, but it's a change in the right direction. We have tutorial videos. I think for the recitations, it's hard to replicate this online. Getting people get together in small groups, I don't think that the platform supports that very well. But we basically have the teachers sort of do solved examples in videos, and we provide that for the MOOCs. We also have computer-graded homework. We spend most of our time on the computer-graded homework. For me, this is make it or break it for the MOOC. I need to give homework that I expect will prepare the students to do the final exam. And we had computer-graded exams for the MOOC. So for the MIT students, we kept everything online except for the exams. We wanted to give them regular exams because we wanted the faculty to sort of feel for themselves that this course really prepared the students to do the same written exam that we usually do. Just because they did problems online, that doesn't mean that they cannot solve problems. We need to make sure that they can solve the same problems. And we kept the recitations because that's the time where people are meeting with the teacher one-to-one. The course the faculty and the students loved it. The students did well. I cannot tell you that they did better because it was a pre-selected group. They did very well, but I cannot really say that we don't have an accurate measurement on how well they did. We asked them on how helpful they thought the different resources and activities in learning the 805 material. And generally you see a lot of green. The most green that you see again is the ability to check answers on MIT. Everyone thought that this immediate feedback is really useful. Ability to view solutions immediately online, the way that we designed it is that the students can solve the problems and they can view the answers immediately. One important thing that we wanted to make sure that doesn't happen is that we asked them, did you more or less of working with others on P-sets? And most people, I mean, there is a little bit of shift where people did things more individually. However, there are 25% that they said they actually worked more with this online format than other courses. And one person actually had a justification because when they get the immediate feedback online and they work together, they know in their discussions that they are on the right track, where if they have no immediate feedback, sometimes they go into different directions and they never converge. So sometimes the immediate feedback outside helped them to sort of converge. I have 1 minute, and I'm going to talk, just mention this course, the effective field theory. This course basically needed to be the most flexible because our graduate students never submit homework on time. They only do the things that are of interest to them. So we designed the course in the same way. We basically said we're going to open all the course material on day 1. We're going to have suggested due dates, but no, we're not going to enforce them. 50% of the course was about a presentation, a research-style presentation. This is the opposite of a huge scale. We had only 12 people finish the course. 2 students took it at MIT for credit. I mean, at MIT, this course is offered once every 3 years. So the idea is that now the MOOC is open. In theory, graduate students can take it any time. We'll just send them to the course. We'll ask them to finish the material. And once they finish it, they could ask to get credit for it. And I think that's, with this way, we actually make the course, we make it possible to offer these courses more often. Even if we do it with an instructor, I mean, the instructor is only expected to spend 2 hours in office hours or in discussions with the students. So it's not a huge time for the instructor to actually offer the course. And I think this could change the way that we offer courses for graduate students and for upper level undergraduates. We can actually offer these courses more often. because of the online platform, and we can open them to others in the institution. So I think I'm going to stop here. I don't know if we have any time for questions.
We have about 1 minute for questions while we switch out to the next speaker. Is Eddie or Frank going to be giving the talk? Eddie?
Both.
Both? You're both Eddie and Frank. That is awesome.
We're both tag team. So let's see if we can have
Yes.